Hello students, welcome to the second lecture of three-dimensional geometry and vectors. First we are doing three-dimensional geometry, and in the last lecture we studied about rectangular coordinate system in three-dimensional geometry. In this particular lecture we are going to study about direction cosines of a line. What do we understand by direction cosines? So actually the direction of a line is being decided by its direction cosines. This is a mathematical way in which we define the direction of a line. If we have a space and I am taking x, y and z axis, keep one thing in mind that x, y and z axis can be taken in any order, but it should be taken care that it is following the right hand thumb rule. That is x to y, if you will go, thumb should point towards positive z axis. So if I take, suppose, this as x axis and this as y axis, so in that case x, which is coming outside of the plane, this x is coming outside of the plane. I hope you are seeing it clearly that it is coming outside of the plane. So x with y, z should point upward. So positive z should be upward and negative z should be downward, not opposite. So this you have to always keep in mind that you can take any one of the axes as x, y or z in any order, but you have to follow the right hand thumb rule. If I take this as x axis and this as y, so x, y and outside will be z, not inside. So after knowing the right hand thumb rule of drawing a rectangular coordinate system in three-dimensional geometry with its axis as x axis, y axis and z axis. Now if there is a line somewhere, anywhere, suppose there is a line here and we are talking about its direction cosines. So before knowing about direction cosines, we should also know about direction angles. So let us take this line parallel to itself such that it passes through the origin. In that manner we can easily understand what does it mean. So this black line is being translated parallel to itself and now it is passing through origin. This line is passing through origin. This is a straight line passing through origin and this is parallel to the given line. So if we consider the directions, so directions will not be affected by translating it parallel to itself. Now this line is making some angle with the positive x-axis. This angle, suppose alpha, it is making some angle with the positive y-axis, that is beta, and this is also making some angle with the positive z-axis, that means gamma. Sorry, till here. So a line can make angles with x, y or z axis and we call those angles as alpha, beta and gamma. These are the direction angles. So alpha, beta, gamma can be said to be direction angles of a line. Here one thing is very important because generally students get confused at later stage if we don't study right now, that there is two set of direction angles of a line. Why is it so? Because line has two directions. You know this, there is a line segment. Line segment has no direction. It is only a part of a line. There is a ray. Ray is actually pointed towards one direction infinitely. And there is a line which is actually pointed both the direction. So if you rightly draw it, it will be something, it has two opposite directions. So if this line is making an angle alpha with the x-axis, this direction will make an angle 180 degree minus alpha with the positive x-axis. Similarly, this direction will make an angle with y-axis also, which will be actually 180 degree minus beta. This would be 180 degree minus beta. Similarly, if this is gamma and if we want to take from the from this direction, so in that case you will see that this is 180 degree minus gamma. So we also have two sets of direction angles. One is alpha, beta, gamma if it is pointed thisward, if it is pointed backward, downward, or some other direction, opposite direction, then the direction angles will be 180 degree minus alpha, 180 degree minus beta, and 180 degree minus gamma. These are also the direction angles of the same line. Now what is direction cosine? If you take cos of alpha, cos of beta, and cos of gamma, just taking cos of these angles, these values are denoted by L, M, and N. So these L, M, N are called direction cosines of the line. For example, we have been given a line which is making angle 60 degree with x-axis, alpha is 60. It is making an angle 120 degree with y-axis, and it is making 45 degree with z-axis. So in that case, can you tell me what is L, M, and N? So just pause this video and find it out, and then cross check with my answer. So L will be equal to cos of 60 degree, which is actually half, and when we come to M, it is cos of 120 degree, which is minus half, and if we come to N, it is cos of 45 degree, which is 1 upon root 2. So basically this particular line has direction cosines as half, comma, minus half, comma, 1 upon root 2. This is a direction cosine. But as I said earlier, that a line does not have a unique direction cosine. A line has two sets of direction cosines. One is this one. So can you tell me what will be the other one? So if you see the angles, one is alpha, another is 180 degree minus alpha. So what will be cos of 180 degree minus alpha? This will give you minus cos alpha by allied angle rule of the trigonometry. This will give you minus cos beta, and this will give you minus cos gamma when you will apply cos on them. So this will be actually minus L, minus M, and minus N, just opposite of LMN in sign. So this is a set of direction cosines of the line. Another set will be minus half, plus half, minus 1 by root 2, just having the opposite sign of LMN. This don't do that minus half with minus half or half with half. Okay, don't combine like that. There are only two sets of direction cosines. There is not 8. Generally people get confused that if this can be plus minus, this can also be plus minus, this can also be plus minus. So make all the combinations, and there will be 2 into 2 into 2, 8 set of direction cosines. It is not so. There is only 2 set of direction cosine. One set of direction cosine, whether something will be positive or something will be negative, and the another set of direction cosine where all the values will be just of the opposite sign. Okay, so we have L, M, N, a set of direction cosine. Another will be minus L, minus M, minus N, another set of direction cosine of a line. Now if I talk about direction cosines of axis, we have x-axis, y-axis, and z-axis. These are actually also lines. So what about these lines? Do they also have direction cosines? Yes, they do have direction cosines. If you see x-axis, what is the angle which x-axis makes with itself? That is 0 angle. What is the angle which it makes with the y and z axis? That is 90 degree. So these are the direction angles of x-axis. If you take the cos of them, you will get L is equal to cos 0 1, M is equal to cos 90 0, n is equal to cos 90 0. So 1 0 0, this is the direction cosine of x-axis. Similarly, if you talk about the direction cosine of y-axis, that will be 0 1 0, and similarly for z-axis 0 0 1. We can have another example also, like we have direction angles 60 degree, 150 degree and 90 degree of a particular line. These are the direction angles. So if you take the cos of these angles, so what will happen? Cos of 60 will be actually half. Cos of 150 degree, that will be actually minus cos 30, which is minus root 3 by 2, and cos of 90 will be 0. So L, M, N, these are the direction cosines and these are the direction angles. So there would be another direction cosine of the line also, which will be minus half plus root 3 by 2 and 0. So we may have such combinations. One thing which is to be kept in mind is the relation between L, M, N. To just try to prove this relation, which you have to remember also, that L square plus M square plus N square is always equal to 1. Even the examples which I have taken, there also you can see that this is being followed. If this is not being followed, then the line will not exist. Okay. So here 1 by 2 square will be 1 by 4, minus root 3 by 2 square will be 3 by 4, and 0 square will be 0, and it will sum up to 1. So this is a very important identity which we have to remember. So just try to prove this identity, that for any line in the space, its sum of square of the direction cosines is always equal to 1. So I will just tell you again. You can pause the video and just check that whether it is true or not. So what I am doing over here, I am taking a line, and this line is having the direction cosines given as L, M, N. So L, M, N are the direction cosines. What are L, M, N? L means cos alpha, M means cos beta, N means cos gamma. So let us draw the coordinate system also. So what am I doing? This is x dash line, this is y dash line, and this is z and z dash line. So now I want to know that what does cos alpha, cos beta, cos gamma actually mean. So if I take this green line, and let us draw this green line parallel to itself passing through origin now. So I am drawing this red line. This is parallel to the green line and the direction is not affected. So whatever the direction cosines of the red line, same will be the direction cosines of the green line. So what is the angle it makes with the x-axis? This is alpha. It makes an angle beta with y, and this makes an angle gamma with z-axis. Okay. We are taking this side. We can also take this side also, no problem. So can you tell me what is cos alpha? So basically, when you project this line on the x-axis, okay, what do we mean by projecting a line? Like this is x-axis and this is a line. So when we project this line on the x-axis, we draw up a perpendicular from a point on it, and this is the angle alpha. So cos alpha is actually base upon hypotenuse. So this position is the base. That will be actually the x coordinate of this point. X comma y comma z are its coordinate. So this will be x, and this hypotenuse is suppose r. So you can say that cos alpha is actually x upon r. Similarly, we come to cos beta, and cos beta will be y upon r, and cos gamma will be z upon r. Simply we are drawing perpendiculars from a point on the line on the x-axis, y-axis and z-axis. We are getting the values of the x-coordinate, y-coordinate and z-coordinate, and we are dividing that by the length of the line from origin to that point, which is r. Now we know, just as I took an example of a cuboid, if you remember, let me draw it again. This is a cuboid which we have been given, and then if we take two diagonally opposite points, so I'm taking a point P here and I'm taking a point Q here. These are diagonally opposite points. So what happens that the distance PQ, which we are calling here as R, the hypotenuse, is equal to root over x square plus y square plus z square. That is its x projection, its projection on y axis and its projection on z axis, which we also say as length, breadth and height. So if we square L and add to m square, then add to n square, what we get is x square upon r square is common to everyone, so we can take as LCM, plus y square plus z square. So therefore L square plus m square plus n square can be written like this. From here, x square plus y square plus z square is actually r square. So this is r square upon r square, which is finally 1. This is the result which I wanted to prove to you, and this is a very important result. Whenever you take direction cosines, this identity must follow. L square plus m square plus n square should be equal to 0. Now if we have been given two lines and we have to find the angle between those two lines, how do we find the angle between those two lines? If we go into the proof, so that will be more helpful in vectors. Right now we will have a rough understanding of the situation. So there are two lines. One is having direction cosine L1, M1, N1. Another having L2, M2, N2. And you have to find the angle between these two lines when their direction cosines are already given to us. So cos of theta would be actually L1 into L2 plus M1 into M2 plus N1 into N2. The reason which you can understand for now, later in vectors we will see further, that this is actually representing a vector. Some basic understanding of vector I think you know. So this is a vector with these three components along x, y and z. And all of these three components are unit vectors. So you can call that this line A is actually L1 I cap plus M1 J cap plus N1 K cap. And similarly another line which is B is L2 I cap plus M2 J cap plus N2 K cap. Now when we go to vectors, we know that A dot B is actually mod of A into mod of B into cos theta, where theta is the angle between them. So what is A dot B? If you take the dot product of these two, by knowing the method that I dot I cap, J dot J cap and K dot K cap will be 1, whereas I dot J, I dot K, J dot K all will be 0. So in that situation, A dot V will be L1 L2 plus M1 M2 plus N1 N2. We will see this in vectors also later. Modulus of A. So can you tell me what is the modulus of A? So mod of A is nothing but root over L1 square plus M1 square plus N1 square. And if you see L1 square plus M1 square plus N1 square, we already know that this is equal to 1. Similarly, B mod will also be 1. So 1, 1 and finally cos theta. So this is a manner in which we can prove that the cos of the angle between two lines whose direction cosines are given can be written like this. two cases which we generally discuss separately is that if the lines are parallel, then what will happen in that situation? If these two lines are parallel, they are not intersecting, that means the direction cosines will obviously be equal. We don't have to take different direction cosines because all parallel lines will have the same direction, so their direction cosines will also be same. If lines are perpendicular, in that case the angle theta will be 90 degree, and we all know cos of 90 is 0. So L1 L2 plus M1 M2 plus N1 N2 would be 0. So this is actually the two particular cases. Otherwise the general formula is this one. So this is about the direction cosines. I hope you have understood this lecture. I am leaving this lecture and I will come to another lecture which will be about direction ratios, but there we will study a question first, and I am giving you the question here and you will solve that question, and then we will discuss in the next lecture where we will start direction ratio later. So what is the question? It says that there are two lines whose direction cosines are something, and their direction cosines are actually related by two relations. One relation is that we have L minus 5m plus 3n. L minus 5m plus 3n is equal to 0, and 7l square plus 5m square minus 3n square is equal to 0. So there are two lines and both the lines have the direction cosines such that both the direction cosines are satisfying these set of relations. Whether you take L1, M1, N1, that will also satisfy both of them. Whether you take L2, M2, N2, that will also satisfy both of them. So can you find what is L, what is M, and what is N for the individual lines, both of them? So this is the question which we will discuss in the next class. By then be prepared, and we will also see direction ratios. Thank you, students.